Hello everybody, welcome to part 2 of memory management for MS-DOSX. Luckily, this lecture is much shorter. There's a little bit more to the lab this time. It's a new lab, so if there's any bugs in there, hopefully we will shake them out quickly. We'll respond to any problems that you might have. This one, we'll keep this one, like I said, short. Next semester, we're probably going to chop that last one in half. I apologize for how long that went. It's kind of a big topic and has always been a big topic. And actually, it'll continue to be a big topic, and I'll talk about that in just a second. So, as a quick sidebar, especially for this lab, this is what an empty class declaration looks like. You'll see this in the lab. We're just using this as a placeholder object. We don't need to extend anything. It doesn't need to be put into any categories. But we want to have a separate object of our own that's been subclassed off of NS object. And so you'll see this syntax, just so that it doesn't throw you in the labs. So there is, and we didn't mention this last time for last lecture, but there's a message that NS objects also respond to that is retain count. So not only do they respond to release and retain, but they have a internal message called internal method called retain count. And your objects normally return the actual retain count of that object. So if you do an allocate and a retain and then another retain, and you call your object retain count, you should get back 3. Do a release, get 2, release 1, release. You can't call it again. You can't call retain account again, or your program will crash. And you'll see some of that today in the lab. NS objects and internal COCO and foundation objects will return values that look like this. Ginormous numbers that are usually like the maximum unsigned long number, maximum number that can fit in an NS integer or NS unsigned integer. Typically, the legacy reason for that is they're trying to protect you and not let you release things out from under yourself. So you can't rely on retain counts that come from, you can't normally rely on retain counts that come from foundation objects or COCO objects, objects that come from the UI kit, objects like that. And then auto release that we talked about before and you're going to get some more practice with today makes this even more difficult to figure out what this retain count value actually is. So the bottom line, don't rely on retain counts unless you're debugging your own objects and you want just another point of view about your memory management. It's not something that you want to rely on when you're practicing your memory management. Learn how to do it correctly. Learn what causes retains and releases. Learn when to use them. Learn what gets allocated to auto release or what gets put into auto release pools, and when auto release pools get released, you will be a much better programmer for it. And a lot of this stuff actually that you're learning about memory management and garbage collection translates to Java and translates to some other, will translate to C++'s new garbage collection, C++11's garbage collection, etc., etc. But the bottom line for retain count, you can use it. You'll use it in the lab. You'll see it in the lab. You'll kind of see it in a live setting. But it's not something that you want to rely on in production code, in code for actual apps that you're writing. Here is an excellent example of this, and this is actually makes Objective-C programmers who program for a little bit of time laugh very loudly. The overridden dealloc method, while your object's retain count is not 0, release. Do it again until your retain count is 0. Then when you're done, do super dealloc. Why would you do this in the first place? What do you think the initial thinking was in the first place for this?
probably forgot to release something.
Yeah, they probably forgot to release something, or they're leaking a whole bunch of memory, and so they figure this will make sure that they get rid of their objects, and especially if they litter this throughout all of their classes, they'll make sure that they always get rid of their objects. What is so harmful about doing this? Think about subclasses and parents and superclasses. What if this is part of a chain of objects? What if this is an object that's in 3 different sets, and one of those sets gets released? So it calls dealloc and starts trying to decrement the retain count. Also, dealloc normally isn't called until the retain count is hit 0 anyway. So this is just kind of overall a silly piece of code, and hopefully just looking at it will kind of turn on some light bulbs, so that if you find yourself starting to try and work your way around the memory manager, or put in fixes and patches to try and take care of any memory management problems that you might be having, think of this as a good example of what not to do. So another thing that you want to do is avoid cyclical references. You'll see this start to happen as your projects grow larger and larger, especially as you start having more and more views and windows and objects that have pointers to other objects that have pointers to other objects. You'll start to find that you'll have pointers to objects that will have pointers back to their parent object. It's a pretty common paradigm. In a reference counting system, it can be a nightmare. That's because if your parent has a reference to the child has a reference back to the parent again. When the parent's release gets called, because the child has also got a reference to it, its dealloc is never going to be called. So it will never release the child, which will never release the parent, which will never release the child, which will never release the parent. So this will leak. So the guideline for this, for cyclical references, the child never retains its parent. You can have a pointer back to your parent, but you don't retain your parent. And the parent is defined as the creator of a child, like a factory method that creates a child, or an object that holds a child as one of its instance variables. This website that'll be on the slides has got a lot of really good information about release and retain cycles. This is a pretty common problem as your projects grow larger and you start having more and more subclasses of objects. But for the general rule, parents retain children, and children don't retain parents. So we talked about auto-release pools. You're going to get some more practice with those today. Here's an overall kind of diagram of the way that auto-release pools are handled, at least for OS X. iOS has a subset of this. The concept is generally similar though. So here's where your program starts at launch, calls your main, which typically calls NS application main, which is, if you look at boilerplate code, when you create a new project, you'll see the main.m file has a call to nsapplication.main, and that's it. That's usually all that it does, because NS application main is responsible for handling. It's an umbrella class that handles everything that your application needs in terms of picking up events and when windows cross over other windows, when data comes in from the network. So NS application is your kind of overarching object. That file, your main file, is typically very small. It's just a call to create this new NS application main and run it. When that runs, when that starts, it creates an auto-release pool. Then an OS X application goes into what's called the run loop, and you're going to see this more and more often as we start talking about things like timers and controllers. You'll see this in later labs. But for now, you can just kind of think of it as a general black box where your program will just sits in a loop waiting for events to happen, waiting for network traffic to come in, waiting for the mouse to move, waiting for the keyboard to be pressed, waiting for trackpad events, gesture events. Your application is basically just kind of like an event server. It picks up an event, it processes an event, and then when your application is done processing the event and you come back out of your code that you've written as a chain. Let's see how I want to put this. And let's see what's a solid way to put this. So the reason that I'm thinking about this is that most people have this really fuzzy definition in their head about when this auto release pool gets released. And if an object gets put into the pool, am I going to have it 2 calls later, or am I going to have it back up the chain? When is it going to get released? Well, it's still that object is still active and live and can still be retained until you come all the way out of your event loop. So typically you pick up an event, you process that event, and that may create objects. It may create, say, a string, for example. It may create a temporary string. It may put it in the auto release pool. That string stays around until this event loop finishes and the pool gets drained. You're gonna get some practice with this during the lab. So if it still feels pretty fuzzy, which it probably will. It does for most people. Practicing with this will help. Yes?
Is it safe to say that it drains the pool just before it waits for another external event?
Yes, exactly. So the event handlers, sitting there, you can kind of think of it as just cycling away, doing its own little background tasks. When an event comes in, say a key press comes down, you get a key press event. You're going to practice these later on when we start talking about events. As you go through and process that key event and you create objects or retain and release objects, as it comes all the way back out again to this higher level before you were called, which is basically the event loop that's running in this application main. When it comes back out again is when it drains the actual pool. Then it goes back and processes the next event, which any objects that get added to the pool will get released. And then process the next event, come all the way back out, drain the pool. You're going to get some practice with this today. So if this is still kind of unclear, ask again after the lab if it's still unclear, because we go over this quite a bit. Then when your when your program is all finished, when your application is all finished, then it actually releases the pool. The pool is an actual collection, and you're going to see that also in the lab. So this create auto release pool is an actual call to creating a collection, and you get to figure out what kind of collection that is. Adding objects to the pool is actually just adding objects to a collection. There's no magic to it. At the very end, when you release the pool, it's just like a collection release, which calls release on all of the objects.